Mill's methods are ways of identifying the causes of particular or general effects. So the first thing we need to do in order to get an understanding of Mill's methods is to understand what causes and effects are. A cause is an object or event that brings about an effect. An effect is a change in the normal state of some object or event. It is the product of some cause. The normal state of some object or event is defined by the typical pattern of behavior indicated by the history of the object or event. So when we want to know what the cause is of a particular effect, we are interested in finding out what object or event was responsible for bringing about a change in some other object or event. Notice that the terms cause and effect are relational terms. They are defined in relation to each other. You cannot have a cause without an effect, and you cannot have an effect without a cause. Also, do not confuse the word affect with the word effect. Affect as a noun refers to something like feelings or emotions. As a verb, affect refers to the act of having an effect on something. Causes affect objects or events, but by doing so, they bring about certain effects. Now, these are very general definitions for causes and effects. They may seem to suggest that causes and effects are very simple, but this is far from the truth. Cause-effect relationships can involve many factors. Consider, for example, a scenario in which a rock was thrown at a window and the window was broken. Now, you might think that this case provides a simple example of a cause and an effect. The rock is the cause and the window breaking is the effect. However, would the rock alone account for the breaking of the window? Wouldn't we also have to consider the weight of the rock, the velocity or speed the rock was traveling when it hit the window, the angle at which the rock was thrown, the density of the window, and how the rock actually came to be thrown at the window? All of these factors may also be regarded as causes of the broken window. These various causes constitute a causal network. Every effect occurs within a causal network. A causal network is a set of conditions that bring about an effect. However, in ordinary life as well as in the sciences, we are often concerned with identifying the precipitating cause of an effect. The precipitating cause is the object or event that is directly or immediately involved in bringing about an effect. It is sometimes referred to as the immediate cause. In such cases, we are interested in either the sufficient condition that brought about the event or the necessary and sufficient condition that brought about the effect. I will discuss causes in terms of necessary conditions, sufficient conditions, and necessary and sufficient conditions in the next slide. However, before we get to those concepts, I want to discuss remote causes. Although in most cases we are interested in precipitating causes, sometimes we are interested in remote causes. A remote cause is something that is connected to the precipitating cause by a chain of causal events. The best way to understand a remote cause is by considering it to be an object or event that eventually led to the precipitating cause bringing about some effect. For example, consider the recent happenings with George Zimmerman. Many individuals were upset about the jury verdict, and one reason that was cited was that George Zimmerman proceeded to follow Trayvon Martin even after Zimmerman was advised to stay in his vehicle. Zimmerman's act of following Martin is a remote cause of Martin's death. Zimmerman following Martin is linked through a causal chain of events to the eventual death of Trayvon Martin. However, simply because a cause is a remote cause does not mean it is not important. A remote cause may be understood as a necessary condition, a sufficient condition, or a necessary and sufficient condition, depending on the causal relationships involved in the causal chain that link the remote cause to the precipitating cause. As mentioned, causes may also be understood in terms of necessary conditions, sufficient conditions, and necessary and sufficient conditions. We actually discussed these three conditions when we spoke of conditional statements. If you recall, a conditional statement, which is typically put in the form of if X then Y, has an antecedent and a consequent. Furthermore, in some cases, the antecedent and the consequent will be related such that the antecedent is the sufficient condition for the consequent, and the consequent is the necessary condition for the antecedent. Furthermore, when we spoke of biconditionals, which are typically put in the form of X if and only if Y, we discussed how the x and y are both necessary and sufficient conditions for each other. Now, when we spoke of these three conditions within the context of conditional statements, the necessary condition was the condition that was required in order for the consequent, which is the sufficient condition, to obtain. And the sufficient condition was the condition that would guarantee that the antecedent condition, which is the necessary condition, would obtain. A condition x that was both necessary and sufficient for y was a condition that was both required for y to obtain and would guarantee that y would obtain. Causes in terms of necessary conditions, sufficient conditions, and necessary and sufficient conditions are very similar to understanding these three conditions in terms of conditional statements. The only difference is that we use the language of causes. A necessary condition as a cause is a condition that must be present in order for an effect to occur, but does not alone bring about the actual occurrence of the effect. A sufficient condition as a cause is a condition that will definitely bring about the effect, but it is not the only condition that can bring about the effect. There are other conditions that may bring about the effect. A necessary and sufficient condition as a cause is a condition that is both necessary and sufficient for bringing about the effect. To illustrate a bit further what these three conditions entail, consider the following. First, any causal claim can be put in the form of x caused y, where x is a cause and y is the effect. Now, given this, a necessary condition as a cause is a condition that must be present in order for an effect to occur, but it does not alone bring about the actual occurrence of the effect. It is a condition that is required for the effect to occur, but does not guarantee that the effect will occur. For example, getting a passing grade or above in your college courses is a necessary condition for you to graduate from college. You need to get at least a passing grade to graduate, but that alone will not guarantee that you will graduate. For example, if you fail to appropriately fill out graduation forms, you will not graduate even if you received a perfect 4.0 GPA. So getting at least a passing grade in your college courses is a necessary condition, but not a sufficient condition for graduating college. A sufficient condition as a cause is a condition that will definitely bring about an effect, but it is not the only condition that may bring about that effect. There are other conditions that may bring about the same effect. For example, getting convicted of drinking and driving in Arizona is a sufficient condition for landing Jane in jail. If anyone gets convicted for drinking and driving in Arizona, you will go to jail. Arizona has a zero-tolerance DUI law where everyone convicted for DUI will spend at least 24 hours in jail. However, being convicted of DUI in Arizona is not the only crime that will land Jane in jail. There are many other crimes that Jane will go to jail for if she were to be convicted of committing them. For example, first-degree murder. So being convicted of a DUI in Arizona is a sufficient condition to land Jane in jail, but it is not a necessary condition. A necessary and sufficient condition as a cause is a condition that is both necessary and sufficient for bringing about the effect. It is a condition that is required for the effect to occur, as well as a condition that will guarantee that the effect will occur. For example, being admitted to the bar in the United States is a necessary and sufficient condition that causes Jane to become a lawyer in the U.S. It is both necessary and sufficient because one needs to be admitted to the bar in the U.S. in order to become a lawyer in the U.S. So it is a necessary condition, and getting admitted to the bar in the U.S. guarantees that one is a lawyer in the U.S., so it is a sufficient condition. Although it may not guarantee that one will always be a lawyer. A lawyer can always be disbarred in some future time. Now that we have an understanding of what causes and effects are and how they may relate to each other in terms of necessary conditions, sufficient conditions, and necessary and sufficient conditions, let us turn to Mill's 5 methods of identifying the cause of an event. John Stuart Mill was a British philosopher. He wrote on philosophy of science, ethics, political philosophy, and economics. He developed the basic principles of experimental science in the System of Logic, which was first published in 1843. And it was in this work that he introduced the following 5 methods for identifying a cause of an effect or a causal relationship. These methods are the method of agreement, the method of difference, the joint method of agreement and difference, the method of residue, and the method of concomitant variation. The first four of our methods are more so focused on identifying the cause of an effect, whereas the last method is more so aimed at determining whether or not a causal relation obtains between one event and another. Now, before we move on to discuss each of these methods in a bit more detail, there are a couple of things to keep in mind. First, John Stuart Mill did not differentiate between causes as necessary conditions, sufficient conditions, or necessary and sufficient conditions. However, we will do so, and we will discuss how his 5 methods may or may not help identify causes as necessary conditions, sufficient conditions, or necessary and sufficient conditions. Second, Mill's methods are not foolproof methods. So employing any one of Mill's methods will not guarantee that what is identified as the cause is actually the cause. However, also keep in mind that any causal argument will be an inductive argument. So the fact that the premises do not guarantee the conclusion is not a weakness of any causal argument. What will be problematic for causal arguments that use something like Mill's methods to support its conclusion is the way in which the premises are actually related to the conclusion in question. We will discuss more about evaluating causal arguments later on toward the end of this lesson. However, in order to understand how to evaluate causal arguments that employ Mill's methods as reasons, one must first understand what Mill's 5 methods are and how they work. So let us now turn to the first method, the method of agreement. The method of agreement aims to identify a single factor as a cause of an effect by identifying a factor that is shared by several occurrences or positive cases of the same type of effect. The method identifies the cause as a necessary condition of the effect. We would employ the method of agreement in the following way. Our first step would be to create a chart by using each positive case of the effect to define a single row of our chart. And we would use each known possible cause to define a single column on our chart. Then we would place a check or a star in the cell where a possible cause was present when the effect was also present. And we would leave blank or place a dash in the cell where a possible cause was absent when the effect was present. After we have entered all the information we have in accordance with the second step, we would then go on to look for a single possible cause, which is a single factor that all the occurrences of the effect have in common. According to the method of agreement, the factor that is shared by all the occurrences of the effect, i.e., all the positive cases of the same type of effect, is the cause of the effect. So consider this example. In this example, 3 people get food poisoning in a restaurant: John, Robert, and Christina. John ate spaghetti, bread, and the appetizer. Robert ate fish and the appetizer. Christina ate ham, bread, and the appetizer. Now the question is, what is the cause of the food poisoning? Now, because we are dealing only with positive cases of the effect, using Mill's method of agreement would be appropriate since it only deals with positive cases of an effect. In order to employ Mill's method, we would go ahead and create a chart as directed by the first step. We would use each positive case of the effect to define a single row on the chart, and we would use each possible cause to define a single column on the chart. Notice how in our example, all the positive cases are listed in the first column, one after the other. Thus, each positive case defines a single row in our chart. Also, each possible cause is written in a single column across the first row. Thus, each possible cause defines a single column on our chart. Each blank cell would thus lie at the intersection of a positive case of the effect and a possible cause, thus indicating a possible relationship between the effect and the possible cause in question. After creating our chart, we would enter what we know about each situation in which the effect occurred. For example, we know that John ate spaghetti, bread, and appetizer. So we represent this information by placing a check in each cell where the instance of John's food poisoning, which defines the entire second row of our chart, intersects with the columns for spaghetti, bread, and appetizers. For all the remaining cells, we leave blank. Note that in this case, we are using checks and blanks. I will maintain this throughout the lecture. Your text, however, uses stars and dashes. You should be familiar with both. Now that we have entered all the information we know regarding John's case of food poisoning, we would move on to Robert's case and then to Christina's case. So for Robert, we know that he ate fish and appetizer. So we would place a check where the row that is defined by Robert's case of food poisoning, which is the third row, intersects with the column for fish and the column for appetizer. And we would leave the rest of the cells in Robert's row blank. For Christina, we would place a check in the cell where the row that is defined by her case of food poisoning intersects with the column for ham, bread, and the appetizer, and we would leave the rest of the cells in her row blank. Finally, we would see which single column is shared by all the positive cases of the same type of effect. We would do so by seeing which column had a check for every row. Notice how in our example, the appetizer column has a check in every row, and no other column has a check in every row. So the appetizer would be identified by this method of agreement as the cause of the food poisoning. Furthermore, although not specified by Mill himself, the method of agreement identifies the cause as a necessary condition rather than a sufficient condition or a necessary and sufficient condition. Thus, given Mill's method of agreement, we may infer that eating the appetizer is required in order for one to get food poisoning at the restaurant, but we would not be able to infer that eating the appetizer alone would guarantee that someone would get food poisoning. In other words, we could not infer that the appetizer was a cause as a sufficient condition. The reason for this is that the method of agreement only deals with positive cases of the same type of effect. Such evidence alone can only support inferences about what would be a necessary condition. In order for us to have evidence to support the claim that the appetizer was a sufficient condition, we would need to make sure that there are no cases where someone ate the appetizer but did not get sick. The reason for this is that the sufficient condition is defined as the condition that will guarantee whatever it is that the sufficient condition is a sufficient condition for. So if among the cases where no one ate the appetizer, we also find that no one got sick, then we can conclude that the appetizer was also a cause as a sufficient condition. But if we were to find a case among the negative cases of the effect where someone did not eat the appetizer but they also got sick, then we would be able to effectively eliminate the appetizer as a sufficient condition, since the case where someone ate the appetizer but did not get sick would be proof that the appetizer would not guarantee the effect of the food poisoning, thereby making it impossible for the appetizer to be a sufficient condition. Thus, the method of agreement only identifies the cause as a necessary condition because it is only concerned with all the positive cases of the effect and what they have in common. It does not consider instances that may or may not prove the cause to be a sufficient condition. It does not consider negative cases of the effect in question. The method of difference, on the other hand, does consider such cases, so let us turn to the method of difference. However, before doing so, let me make one note. In most cases, the method of agreement would be employed only because no information is available regarding negative cases of the effect. As with any of the 5 methods, you need to first look at what kind of information you have to work with before you decide on which method you would employ. The method of difference aims to identify a single factor as the cause of an effect by identifying a single factor that is present in a single positive case and absent in a single negative case. Also, both cases are exactly the same in every other way, except for the absence and presence of a single factor. So the method of difference is restricted to only 2 cases, one positive case of the effect and one negative case. Also, the 2 cases that are used by the method of difference should be very similar in every way except for one. Furthermore, the method of difference identifies the cause as a sufficient condition of the effect. In order to employ the method of difference, we want to first create a chart by using the positive case of the effect to define a single row and the negative case of the effect to define another single row. Then we use each known possible cause to define a single column. Notice how this is different from the method of agreement. For the method of agreement, we only use positive cases of some type of effect. Here, we are using both a positive and a negative case of the effect in question. Also, since we are only dealing with one positive and one negative case of the effect, we are not dealing with types of effects. We are instead dealing with a particular effect. Our second step is to place a check or star in the column where a possible cause was present for any of the 2 cases, and leave blank or place a dash where a possible cause was absent for any of the two cases. Finally, we look for a possible cause which is assumed to be a single factor that is present in the positive case but absent in the negative case. According to the method of difference, this factor that is present in the positive case but absent in the negative case will be the cause. Let us see how these steps would work in practice. Consider our example here. John and Robert went out to eat. John got food poisoning and Robert did not. John had hamburgers, french fries, tea, and pie. Robert had hamburgers, tea, and pie. Now, what is the cause of John getting food poisoning? In order to employ the method of difference, we first set up the chart as indicated by the first step. Note that the actual procedure for setting up the chart for the method of difference is pretty much the same as the procedure for setting up the chart for the method of agreement. The differences are that for the method of difference, we are including both positive and negative cases of the effect, and we are only working with a total of 2 instances. But how and where we place each case and each possible cause within the chart is essentially the same as the method of agreement. So you can see that each instance, one positive and one negative case, will define a single row, and each possible cause will define a single column. Now, after setting up our chart, we want to input our information as instructed by the second step. Here too, the actual application of the second step is pretty much the same as the second step for the method of agreement. You place a check or a star where a possible cause was present during either the negative or positive case of the effect, and you leave a blank or place a dash where a possible cause was absent for either the negative or positive case of the effect. So you can see with our example, since John had hamburgers, french fries, tea, and pie, and he got food poisoning, this tells us that hamburgers, french fries, tea, and pie were all present during the occurrence of the effect. So we place a check in the cells where the columns for these items intersect with the row for John's case. Also, we can see that for the row that represents Robert's case, we only have the cells that intersect with hamburger, tea, and pie checked. This is because, according to the information we have, Robert only had these 3 items. Finally, we want to see if there is a single condition that is present in John's positive case of food poisoning, but absent in Robert's negative case of food poisoning. Notice how French fries were present in John's case, but absent in Robert's case. Also notice that both John and Robert have in common all the other 3 factors. Thus, the method of difference identifies the French fries as the cause of John's food poisoning. Furthermore, unlike the method of agreement, the method of difference only identifies the cause as a sufficient condition. The reason for this is because a sufficient condition is defined as the condition that will guarantee that the effect will occur. So if we have evidence that a positive case of an effect has everything else in common with a negative case of the effect, except for a single factor, then by elimination we can infer that the single factor alone brought about the effect. Thus, if we had the single factor, the effect would be guaranteed. This, of course, does not mean that no other causes would be able to bring about a similar type of effect. It simply means that for the effect in question, this single cause was capable of bringing about the effect by itself. Now, you might be concerned with the phrase bringing the effect about all by itself. You may want to argue that the information we have is also consistent with the conclusion that hamburgers was a necessary condition and that all the other 3 conditions along with hamburgers are jointly sufficient. Given only the information regarding the 2 cases, this is a reasonable argument to make, and it brings out one of the limitations of Mill's methods. One assumption that all 5 methods makes is that there is only a single factor that is the cause of an effect. So Mill's methods overlook the possibility that causes that are involved are more complex than single factors. One lesson to take home from this is to regard Mill's method as a starting point for determining the cause of an effect, rather than regarding these methods as procedures that will lead to decisive conclusions. For even if it were the case that the cause of John's food poisoning was that he had hamburgers, french fries, tea, and pie together, so they are jointly sufficient, Mill's method would still be able to identify the french fries as a cause, which would allow for further testing and perhaps progress towards identifying the necessary and sufficient causes. However, you should also note that if we take into consideration pre-existing knowledge about how one gets food poisoning, we can eliminate the explanation that all 4 food items were necessary and jointly sufficient. This is because we know that food poisoning does not work in this way. We get food poisoning anytime we consume a single item that was either undercooked, spoiled, etc. So even though the method of difference is not able to eliminate the explanation that food poisoning was jointly caused by all 4 food items, we were able to do so by accessing our background knowledge about the world. Note that this is something you will have to do when evaluating inductive arguments. Now, with this in mind, let us move on to the next method of identifying causes. Notice that the joint method of agreement and difference is not the simple combination of the method of agreement and method of difference. Unlike the method of agreement, the joint method deals with both positive and negative cases of the effect. Also, unlike the method of difference, the joint method deals with 2 or more cases where the effect is absent or present. Furthermore, the cases that the joint method deals with may be different in more ways than one. Now, keeping in mind how the joint method differs from simply the combination of the method of agreement and the method of difference, the joint method identifies the cause as a necessary and sufficient condition of an effect of a certain type. In order to employ the joint method, you first create a chart similar to the way we created charts for the first 2 methods. However, unlike the first 2 cases, we may have more than one positive case of the effect and more than one negative case of the effect. Also, these cases may be similar from each other in more than one ways. So we would use each case, positive or negative, to define a single row, and we will use each known possible cause to define a single column. Note that since we may be working with multiple positive and negative cases with this method, it is best to group all the positive cases together and all the negative cases together. Next, we place a check or star in the column where a possible cause was present and leave blank or place a dash where a possible cause was absent for each negative and positive case. Finally, we look for a possible cause, which will be a single factor, that is present in all and only the positive cases and absent in all and only the negative cases. According to the method of difference, this factor that is present in all and only the positive cases and absent in all and only the negative cases will be the cause. Let us discuss an example where this method is applied. In this example, 4 people go out to dinner. 3 of them, John, Robert, and Christina, got food poisoning. John ate spaghetti, bread, and an appetizer. Robert ate fish and the appetizer. Christina ate ham, bread, and the appetizer. Kristen ate fish and bread, and she is also the only one who did not get food poisoning. Now, what is the cause of the food poisoning? Notice that in this case, we should not simply apply the method of agreement since we have information regarding a negative case of the effect as well as information regarding positive cases of the effect. We also cannot apply the method of difference because we are working with more than 2 cases. Thus, we are interested in identifying the cause of a certain type of effect. With these in mind, we first start by setting up our chart as with the first 2 methods. However, we will group all the positive cases together and all the negative cases together. We happen to have here only one negative case, but you may have more than one. After setting up our chart, as with the first 2 methods, we input our information. So for John, we put a check in the cell where the row that represents his case intersects with spaghetti, bread, and appetizer. We also follow a similar procedure with the rest of the cases, positive and negative. After we have completed filling in our chart in accordance with the information we have, our final step is to identify the possible cause that is shared by all the positive cases and is absent in all the negative cases. As you can see, the appetizer is the only possible cause that fulfills these 2 conditions. So according to Mill's joint method, the appetizer is the cause of the food poisoning. Furthermore, the appetizer is the cause as a necessary and sufficient condition. The reason why the appetizer is a necessary condition is because the various differences between the positive cases suggest that no condition except for the appetizer can be a necessary condition for the effect. More specifically, since there are positive cases where each of the four possible causes are absent, this indicates that these four possible causes cannot be necessary conditions. Remember that a cause as a necessary condition is one that is required or needed in order for an effect to occur. So if there is a positive case where a certain factor is absent, this suggests that the factor is not a necessary condition. And if we find a possible cause that is present in all the positive cases, then this suggests that the possible cause is a necessary condition. The reason why the appetizer is a sufficient condition is because the joint method illustrates how appetizers alone will bring about food poisoning. It does so by showing us that none of the negative cases have this condition. The appetizer as a possible cause is absent in the one negative case that we have. Thus, the fact that all the positive cases have this factor in common and all the negative cases do not have this factor in common suggests that only this factor is needed to bring about the effect. So Mills' joint method suggests that the appetizer is also a sufficient condition for bringing about the effect. Our next method is the method of residue. This method aims to identify a single factor as a cause of a specific effect, where the two are a part of a complex set of causes and effects. It does so by eliminating possible causes and their known effects. It subtracts from a complex set of events some causes that are already known to have certain effects. Furthermore, this method may be used to identify conditions that are necessary, sufficient, or necessary and sufficient. So unlike the first three methods, the method of residue alone will not be able to distinguish between these kinds of conditions. The way to go about employing the method of residue is slightly different from the first three methods. Note that I will show you one way to carry out the method of residue here. This way is different from what the text has introduced. You should be familiar with both. The way I set up the method of residue is to first create a chart by using each effect under consideration to define a single row, and I use each known possible cause to define a single column. Also, note that although the method of residue seems similar to the first three methods, there is a fundamental difference within this method compared to the first three. With this method, you will be working with multiple effects of various kinds. Then, drawing on past experience, we place a check in each cell for every known cause and effect relationship that can be identified on the chart. And we place an X in each cell for every cause and effect relationship that is known not to obtain. Finally, after all the causes and effects have been accounted for with the checks and X's, if there is only one cause remaining and one effect remaining, the remaining cause is concluded to be the cause of the remaining effect. Let us see this method in action. Let us say that you went to a barbecue and ate hot dogs, pizza, chips, pretzels, macadamia nuts, and drank soda. Afterwards, you had a stomachache, a headache, and a rash. Also, from your past experience, you know that only hot dogs give you stomach aches, only soda gives you headaches, and hot dogs, pizza, chips, pretzels, and soda do not give you rashes. Given the scenario, what is the cause of the rash? In order to determine the cause, we set up the chart as indicated in step 1. Note how each effect is given a single row. Furthermore, as with the first two methods, each possible cause is given its own column. After the chart has been set up, we will input our information into the chart as directed earlier in step 2. We consider the relevant information about your history, and we account for this information by placing a check where your history reveals a causal relationship between at least one of the effects and one of the causes. We also place an X where your history reveals that there is no causal relationship between at least one of the causes and one of the effects. You can see that we went ahead and placed a check where the stomach ache and hot dog intersect, and we placed an X in the rest of the cells in this row. This is because, according to your history, only hot dogs give you stomach aches. We also know that only sodas give you headaches, so we place a check in the headache row that intersects with the soda column. We also place an X in the rest of the cell for this row. Finally, we place an X in the cells where the row for rash intersects with the columns for hot dogs, pizza, chips, pretzels, and soda. We do this since we know, based on your past history, that these things do not give you rashes. Now, after we have inputted all our information, we can see if there is a single possible cause left unassigned to an effect. We would identify this as a blank cell. If there is such a cause, then that cause would explain the single effect that it is associated with in the column. Given this result, we may conclude by the method of residue that the macadamia nuts caused the rash. Now, as I mentioned earlier, this method does not provide us with a way of determining whether the identified cause is a necessary condition, a sufficient condition, or a necessary and sufficient condition. However, like the other methods, this method provides us with a starting point from which we can pursue further tests in order to determine what is the necessary condition, the sufficient condition, or the necessary and sufficient condition. Mill's final method that we will discuss is the method of concomitant variation. The method of concomitant variation aims to establish a causal relationship between two factors by identifying a correlation between changes in the two factors. A correlation is a correspondence between two sets of objects, events, or sets of data. Note that mere correlation does not conclusively establish a causal relationship. However, it may provide an avenue to pursue further inquiries. Finally, this method only seeks to establish a causal relationship between two factors. The method alone cannot identify which factor is the cause and which is the effect, although sometimes we may be able to do so by considering the temporal sequence of the events being correlated or background information. If one of the events being correlated always occurs before the other event, then it may be inferred that the prior event is the cause of the later event. In order to employ the method of concomitant variation, I will again introduce a setup that is different from the setup introduced in your text. You should be familiar with both. Your first step will again be to create a chart. This time, use one factor to define a single row and use each change in another factor to define a single column. If possible, use the changes in the factor that might be the cause to define each column. Your second step is to input the information regarding changes in the factor used to define the row. Finally, in the third step, you need to look in the chart for a correspondence between changes in one factor and changes in the other factor. If you find that every time one factor undergoes a change, the other factor does so as well, then a causal relationship may be established. Also, note that it need not be the case that the changes detected in the two factors always move in the same direction. For example, an increase in one factor may be correlated with a decrease in another factor and still count as a correlation between the two factors. Let us now look at an example that illustrates the use of this method. Let us say that you want to know if there is a causal relationship between how fast you go in a car, miles per hour, and how many miles per gallon of gasoline you would get. So you set up an experiment to find out. You get your vehicle and you manipulate your miles per hour while keeping track of your miles per gallon for each time you change your miles per hour. When you are done, you have the following set of data. When you're going 0 miles per hour, you got 0 miles per gallon. When you went 10 miles per hour, you got 12 miles per gallon. When you went 20 miles per hour, you got 18 miles per gallon, etc. Note that your experiment provided you with the data that you would use in order to employ Mill's method of concomitant variation. Now that you have some data, you may employ Mill's method of concomitant variation in the following way. First, you set up your chart as indicated by the first step. In this case, we would use the miles per hour to define each column since this factor was the manipulated factor in the experiment. So you would give a column to each of the following miles per hour traveled: 0, 10, 20, 30, 40, 50, 60, 70, and 80. We would also use the second factor of miles per gallon to define a single row in our chart. By doing so, our chart will create cells at the intersection between changes in miles per hour and changes in miles per gallon. Then, according to our second step, we input the information regarding the changes in our miles per gallon as it relates to changes in miles per hour. So since our data suggested that when moving at 0 miles per hour, you got 0 miles per gallon, we would input 0 in the cell where the row for miles per gallon intersects with the rows for 0 miles per hour. We do this for each of the changes in miles per gallon in our data set that is associated with changes in miles per hour. After doing so, our completed chart should look like the one shown here. Now, for the final step of Mill's method of concomitant variation, we want to look at our chart to see if we can find any correlation between changes in miles per hour and changes in miles per gallon. Notice that according to the chart, every time there was a change in miles per hour, there was also a change in miles per gallon. Given this, we may infer that there is some causal relationship between the two factors. Furthermore, in this case as well, we may be able to infer that changes in miles per hour will cause changes in miles per gallon. But this is not due to the fact that we used Mill's method to make this inference. The reason why in this case we may be able to infer that one factor is the cause of the other is due to the fact that the information was collected from an experiment that was set up in such a way as to test whether or not changes in miles per hour would cause changes in miles per gallon. So in some cases you may be able to infer which factor is the cause and which is the effect, but this will not be due to the fact that you use the method of concomitant variation. This concludes our discussion of Mill's 5 methods of identifying causes or causal relationships. Let us now discuss some limitations that these methods may have. When you employ any of these 5 methods, you need to keep the following in mind. First, all 5 of Mill's methods assume that there is only one cause for each effect or non-effect, that the same cause explains each positive or negative case, and that the cause is one of the known possible causes. Since it is possible for all these assumptions to be false, these 3 methods cannot conclusively identify the correct cause. I illustrated this point in our discussion of Mill's method of difference. Remember how our example for the method of difference provided us with evidence that may be used to support the conclusion that what was identified as the sufficient cause may actually be a necessary cause that is jointly sufficient with all the other possible causes. Also, because these methods draw a conclusion about a cause from particular cases, the conclusion may not be easily generalizable. This is not to suggest that no generalizations can be made. What it does suggest is that you need to be aware of how many cases are being relied on in order to draw a general conclusion. The number of cases used will affect the strength of reasoning from particular cases to a general conclusion. So the strength of any causal argument that generalizes from particular cases to a general conclusion will depend on the number of cases the argument considers as reasons to support its conclusion. The more cases that are being considered, the stronger the argument will be. Now that we have some understanding of how Mill's 5 methods work to identify causes or causal relationships, as well as some idea of the limitations of these 5 methods, let us now turn to how these methods are related to causal arguments. As mentioned previously in your lecture on inductive argument forms, a causal argument is an inductive argument that has the following general form or framework. In at least one of its premises, it observes a correlation between 2 or more things or class of things. And as its conclusion, it asserts that one of the things or class of things observed caused the other thing or class of things observed. Now, given this general form, let us see how each of Mill's methods can be used to construct a causal argument. Recall that for our example illustrating Mill's method of agreement, we used a scenario where 3 individuals, John, Robert, and Christina, all got food poisoning when they ate at a certain restaurant. We employed Mill's method of agreement in order to determine what it was that they ate that may have caused their food poisoning. Based on this method, we determined that the appetizer, which was the only thing that everyone ate, was the cause of the food poisoning. Now, based on this information, we can go on to construct the following causal argument. Since everyone who got food poisoning all ate the appetizer is probably the culprit. The premise of this argument is the statement, everyone who got food poisoning all ate the appetizer. And the conclusion is the statement, the appetizer is probably the culprit. Notice how this argument follows the general form of a causal argument. The premise observes a correlation between 2 or more things or class of things. In this case, the correlation is between positive cases of food poisoning and eating the appetizer. The conclusion asserts that one of the things or class of things observed cause the other thing or class of things observed. In this case, the conclusion is asserting, although perhaps implicitly, that the appetizers caused the food poisoning. Furthermore, note how the premises indicates which method is being employed by the type of reason it uses. Here, the reason is a common factor that is shared by all positive cases. Now, when we evaluate causal arguments such as this one, we want to keep in mind how the data and the method for identifying the cause or causal relation is being relied on in the argument in order to draw the conclusion that the argument draws. In this argument, the method of agreement is being used to draw the conclusion that the appetizer was the cause. Now remember, the method of agreement only identifies the cause as a necessary condition and does not support any conclusion about causes being a sufficient condition or a necessary and sufficient condition. However, the conclusion is most likely making a claim about the appetizers being a sufficient condition or a necessary and sufficient condition. So the method employed does not actually support the kind of causal claim that the conclusion is making, which then implies that this argument is a weak argument since the reasons do not provide enough support for the conclusion being probably true. Note that in most cases, causal arguments typically assert that something is either a sufficient condition as a cause or a necessary and sufficient condition as a cause. It is very rare for a causal argument to assert something as a necessary condition as a cause, and when one does so, it usually notes this by explicitly mentioning the kind of causal claim that is being asserted in the conclusion. Here we have the method of difference being used to construct a causal argument. Now recall that the method of difference looks at two particular cases, a positive case and a negative case of the effect in question, and these two cases are similar in every way except one. Furthermore, the method of difference concludes that the one factor that is found in the positive case but not in the negative case is the cause of the effect. So here we have the example of John and Robert. Based on these two cases, we used the method of difference to conclude that the cause of John's food poisoning was French fries. Given this, we can construct the following argument. John got food poisoning and he had hamburgers, French fries, pie, and tea. Robert had everything that John had except for French fries, and Robert did not get sick. So I'd stay away from the fries if I were you. Notice how in this argument you have two sets of correlations that are being observed in the premises. The first premise observes a correlation between John's food poisoning and what John ate, and the second premise observes a correlation between Robert not getting food poisoning and Robert not eating French fries. The premise also notes that besides the French fries, Robert ate everything else that John did. Then the conclusion asserts a causal claim that the French fries will cause people to get sick. This is what is implied by the statement, I'd stay away from the French fries if I were you. This argument, like the one before it, indicates what type of method is being used by the reason it gives. The reasons given here clearly indicate that the method of difference is being used. Once again, when we evaluate arguments like this, we want to consider how the data and the method for identifying causes or causal relations is being relied on in the argument in order to draw the conclusion that the argument draws. In this case, the data is being used along with Mill's method of difference in order to support a general conclusion about French fries being the cause either as a sufficient condition or a necessary and sufficient condition. Now, as we discussed, Mill's method of difference does allow for inferences about something being a cause as a sufficient condition. However, recall that the method of difference deals only with two particular cases, and as such, the conclusion that it draws would only be applicable to the particular cases being considered. So because the argument given here draws a general conclusion about French fries causing food poisoning rather than a particular conclusion about French fries causing John's food poisoning, this would be a weak argument. Note that all causal arguments use particular cases as reasons, so the fact that the method of difference uses particular cases is not really the issue. The problem is that the method itself is intended for drawing conclusions about particular cases, and so it not only uses particular cases, but is limited to the use of one particular positive case and one particular negative case of the effect. However, if we can provide several particular cases that are similar, thus allowing us to compound several uses of the method of difference together, then we should be able to support a general conclusion. This is also the case with the other four methods. In other words, the greater the number of instances that any one of these methods considers, the stronger the reasoning will be from the premises to the conclusion. Here we have the method of agreement and difference being used to construct a causal argument. In this case, we have two premises. The first premise observes a correlation between all the positive cases of food poisoning and eating the appetizer. And the second premise observes a correlation between all the negative cases of food poisoning and not eating the appetizer. Based on these reasons, the argument concludes that the appetizer caused John, Robert, and Christina's food poisoning. Note how in this argument as well, the kind of method that is being used is indicated by the reasons being used. Now this argument is a fairly strong argument. The conclusion is asserting that the appetizer is a cause as either a sufficient condition or a necessary and sufficient condition. It is also making a causal claim about the three particular cases, and these three cases were the cases that were introduced in the premises. So the reasons being offered as premises, which are based on the information given by the joint method, do seem to support the likelihood of the conclusion being true. Remember that the joint method helps identify causes as necessary and sufficient conditions. So regardless of whether the conclusion was asserting that the appetizer was the cause as a sufficient condition or a necessary and sufficient condition, the reasons given would support the conclusion. This is because the reasons are based on Mill's joint method, which identifies causes as both necessary and sufficient conditions. Our next example employs the method of residue in order to construct a causal argument. Now, based on the method of residue, the argument concludes that the macadamia nuts caused the rash. The premises that are given in support of this conclusion observe correlations between the various possible causes under consideration and the various effects under consideration. These known causal relations are then used to eliminate certain causes as a cause of the effect that we are specifically concerned about. In this case, we are concerned with what caused the rash. Note how in this case as well, the reasons being used indicate the type of method being used. With the first three causal arguments that were based on the first three methods introduced, we needed to concern ourselves with how the data and method being used related to the kind of conclusion being drawn. However, the method of residue does not give any indication that the cause identified by the method will be a necessary condition, a sufficient condition, or a necessary and sufficient condition. The cause that the method of residue identifies may be a cause as any one of these conditions. So any argument that is constructed well based on the method of residue will most likely be asserting a claim that what has been identified as the cause is a cause without specifying if it is a cause as a necessary condition, a sufficient condition, or a necessary and sufficient condition. However, if arguments based on the method of residue make such assertions about the cause in their conclusion, then they will be weak arguments because the method itself does not make any distinction in terms of the kind of causes that are being identified. So if we were to regard the conclusion of our example as a causal claim that does not specify whether the cause is a cause as a necessary condition, a sufficient condition, or a necessary and sufficient condition, then this argument would be a reasonably strong argument. And given the principle of charity, where we would interpret an argument in such a way as to give the author the benefit of doubt, we will interpret the conclusion of this argument as being nonspecific about the cause. Thus, this would be regarded as a fairly strong argument. Our final example is a causal argument based on the method of concomitant variation. As discussed, the method of concomitant variation does not aim at identifying an object or event as a cause. Rather, it aims at establishing that there is a causal relationship between the two factors being considered. So a well-constructed causal argument based on the method of concomitant variation will stay away from asserting that some object or event is a cause of another object or event. Such arguments instead assert a conclusion about the fact that there is a causal relation between the two factors being discussed in the premises. For example, consider this argument here. This argument argues that your decision to drive at a certain speed might affect how much money you are going to need for gas. It gives as reasons to support this claim a correlation between how many miles per hour you go and how many miles per gallon you'll get, which was established using the collected data and the method of concomitant variation. Notice how in this argument as well, the kind of method that is being used is indicated by the premise. The claim that there is a correlation between how many miles per hour you drive and how many miles per gallon you get is the conclusion drawn from employing the method of concomitant variation. The conclusion of this argument also simply asserts that there may be a causal relationship between how many miles per hour one travels and how many miles per gallon one will get. This assertion is implied by the conclusion, which states that your decision to drive at a certain speed may affect how much money you're going to need for gas. In evaluating causal arguments that are based only on the method of concomitant variation, since this method only intends to establish that a causal relationship may exist, the strength of any argument that goes beyond this by concluding that one of the factors is the cause of the other factor may depend on a couple of other considerations. First, if our background knowledge indicated that one of the factors was always temporally prior to the other factor, then we may be able to conclude that the first factor is a sufficient condition for the second factor. Such background information allows us to reinterpret the mere causal relationship established by the method of concomitant variation into information about the temporally prior factor being the cause of the later factor. Second, if there are no problematic competing causal arguments that can explain the correlation between these two factors, then we may be able to strongly infer that the correlations indicate that the speed at which one travels is the cause of how many miles per gallon of gas one will get. Third, because this information is consistent with our pre-existing background knowledge of cars and gas mileage, we may be able to infer that this is at least a moderately strong argument. In our discussion of how to construct causal arguments by relying on Mill's method for identifying causes or causal relations, we also discussed some things that we would need to consider when we evaluate these arguments. More specifically, we discussed how determining whether or not the correct method was used is important to determining the strength of some causal arguments, especially for arguments that are based on the first three methods. We want to know if the method used to construct the argument is appropriate for the conclusion put forth in the argument. If the answer is no, then the argument is weakened. We also discussed how the number of observations used would affect the strength of any causal argument, especially one that makes a general causal claim as its conclusion. We discussed how the greater the number of positive or negative cases used, the stronger the argument will be. However, we need to also discuss two more important considerations that need to be made when evaluating any causal argument. First, we need to always consider the relevance of the correlations being used to the conclusion being made. If the correlations observed in the premises are not relevant to the conclusion being established, then the argument will be weakened. So for example, if I argue that the sun causes plants to grow because everyone I know who suffers from depression also suffers from a deficiency in vitamin D, you would most likely regard me as an unreasonable person. The reason for this is that the premise that there is a correlation between the positive cases of depression and the positive cases of vitamin D deficiency that I am aware of is completely irrelevant to the conclusion that the sun causes plants to grow. Now, this is an obvious case where the lack of relevance that the premises have to the conclusion will make the argument weak. But note that not all cases where the premises are irrelevant to the conclusion are this obvious. Second, a final consideration you must make is whether or not there are more reasonable alternative explanations that would explain the correlations that are used in the premises. If the answer is yes, then the argument is weakened. The reason for this is that when we reason about causes of things, we want to be conservative about the kinds of claims we make. What I mean by this is that we want to make sure that we are being consistent with the body of knowledge that we currently have, and we want to keep ourselves from positing new causal relations if there are pre-existing causal relations that can already explain the effects in question. So, for example, consider this argument. Wearing uniforms make people perform more emotion work on their jobs because according to a recent study, there is a correlation between wearing a uniform and the amount of emotion work that one must employ during one's job. This argument is positing a new causal relation between uniforms and emotion work performed on the job. One might think that this is a strong argument, but it is not. One reason is that the correlations alone do not establish causation, and this argument concludes a claim about something causing another thing based on a correlation alone. Another reason is that there is a more reasonable explanation for why there is a correlation between wearing uniforms and the amount of emotional work one performs on their job. That reason is that uniforms are typically worn in jobs that provide services to the public. For example, nurses, bus drivers, flight attendants, fast food restaurant employees all wear uniforms. And service industry jobs typically require their employees to modify their emotional expressions in order to provide consumers with positive experiences. Thus, the fact that wearing uniforms and performing a large amount of emotion work on one's job are both associated with service industry jobs would weaken the given argument that uniforms cause one to perform more emotion work on their job, since the common factor of the service industry job provides a more reasonable explanation of the correlation between uniforms and the amount of emotion work performed. Note that in many cases, the above considerations will involve the use of background knowledge about what the argument is about. This is typical of evaluating the strength of inductive arguments. Remember, unlike deductive arguments, the quality of the reasoning in any inductive argument depends on the content of the argument. In other words, it depends on what the argument is actually asserting in the premises and the conclusion.